Section 6, Video 2. In this video, we will review DRS or Distributed Resource Scheduler. DRS is a preemptive technology, and the target or objective is to ensure load balancing across ESXi hosts. Once a host is added to a DRS cluster, all the host resources, including any VMs, become part of the cluster resources. The distribution and CPU usage and memory resources for all hosts and virtual machines are continuously monitored as part of DRS. DRS transparently compares these metrics to an ideal resource utilization, including current demand and imbalanced target. DRS, based on this information, performs or recommends virtual machines migrations accordingly. And DRS attempts to maintain proper load balancing by either placing the virtual machine on an appropriate host or making a recommendation. As stated earlier, DRS's objective is to ensure all the hosts in the cluster are equally balanced. VMware vSphere clusters allow highly available resources, balanced workloads, and scalability. As shown in the graphics here, see how CPU utilization and memory utilization is measured or mapped across the cluster resources. In order to configure DRS for a cluster, we need to select Edit Cluster Settings in the web client. As shown here, turning on DRS is a simple matter of turning on or selecting the checkbox and then making the appropriate selection. DRS automation level can be manual, partially automated, or fully automated. An organization can make that selection based on their existing policies. A migration threshold ranges from conservative to aggressive and allows how recommendations should be provided by DRS. An organization can also select predictive DRS, which however requires vRealize to be running. And finally, virtual machine automation. We can select at an individual level how it should respond to automation levels. Storage DRS, as the name suggests, is also based on DRS and allows management of storage across the data store cluster. Storage DRS provides space load balancing, I/O load balancing, and initial placement of virtual disk based on space and I/O workload. Again, the objective of storage DRS is ensure that all data stores are equally load balanced, as well as the I/O going to each data store is also balanced. DPM, another technology based on DRS, allows an organization to save on power consumption. When DPM is enabled, it can recommend or place hosts in standby power mode if sufficient capacity is found on other hosts. It can optimize power consumption dynamically. When demand for resources is low, DPM can place hosts in standby mode, thereby saving on power consumption. And as demand grows, DPM can power on hosts to meet that demand. An organization using DPM can save as much as 20% on power and cooling costs, especially during low utilization periods. And DPM can help automate energy management in a data center more efficiently. To summarize, we reviewed distributed resource scheduler including DRS on storage, DRS CPU memory utilization and automation levels, enabling DRS and selecting or configuring DRS in a cluster, and distributed power management. In the next video 3, we will review high availability. Thank you for watching.